Can I get a confirmation from somebody if they can hear me or not? You can type to me in the chat. Okay, good. Thanks. Okay, so we'll start now. So last week, we learned the basics of writing methods and how to evaluate certain expressions as well as assigning variables to situations. So now, another important part of Java, perhaps the three most important parts are like writing methods, writing conditional statements, if else, and also for loops. So today we'll be covering the second most important topic for me personally, which is conditional statements. So let me present this. So first, I would like to go over logical expressions. These are the conditions we usually find in a if-then statement, the part following the if statement. And in Java, there are a few things you can do. First, there is the equals that checks to see if the left-hand expression is equal to the right-hand expression. For example, in this scenario, 4 is equal to 4, so it would evaluate to true. Another thing we can use is the mathematical expression operation of a less than sign or a greater than sign. You can also do a less than equal to sign or a greater than equal to sign. In this scenario, the example I give is 5 less than 4, which is obviously false. So this expression would evaluate to false. Aside from your basic math operations, equals and greater than or less than, you have some logical operations that I want to introduce to you guys. The first one is and the symbol for and in Java is two ampersands. Next is or, which is two. You do two shift it's the shift backslash. It's you do two of it, and it's the or, and then the exclamation point is a not. So I'll show you guys examples of what how we can use these logical operands. So for the and sign, if you have two expressions and you want to see if both of them are true or not, use the and operand. If the expression on the left and the expression on the right are both true, then the entire expression with the and is evaluated as true. Otherwise, it is false. So for this example I give, 4 equals 4. From the top, we know that that's true. And 3 greater than 5. Since 3 is not greater than 5, that would be false. So the entire statement would be false because both of the expressions need to be true in order for it to be true. However, the definition of an or is only one of the expressions, either on the left-hand side or the right-hand side, is true, then the entire expression is evaluated to true. So since the left-hand expression 4 equal to 4 is true, then the entire logical expression is evaluated to true. Not is a pretty simple logical expression as well. Not basically is, if I ask, like, say a question, is 3 not equal to 4? 3 is not equal to 4, so this expression will be true. You can also use it for, usually you would use it for an equal sign evaluation, but you could probably use it for other, in conjunction with other logical expressions as well. And finally, I want to combine a not operand with an and operand. So the scenario I give here is 3 not equal to 4? That's true from above, but and is 3 less than 2? 3 less than 2 is false. So since and requires both expressions on either side to be true, the entire logical expression will be evaluated to false. So does anyone have any questions about that? Sure. I can see you raising a hand. You can type to me in the chat and I can answer your question. Perhaps like if I give more examples, it will be clearer, but these are just some of the. It says that or is not a statement. What says that or is not a statement? Or by itself is not a statement because it's an operand. But okay, so I will type into chat to everyone. This is an or. Oh shoot, everyone in meeting. It's not two capital I's or two L's. It's two. You do a shift backslash and you get the straight line. Yeah, that. And it's not a statement by itself, but it's an operand. Do you need a state? You do not need a space in the middle. You use it as a part of a logical expression. For example, I will show you an example of how to use these logical expressions in the next slide. So be patient, I guess. Okay, so hopefully you can repeat this question to me if after the next slide it still doesn't make sense to you, but I think the next slide will be able to explain it better. So I'll move on for now. So if statement is how we use these logical expressions. Hopefully you guys understood logical expressions because I didn't receive any specific questions regarding that, like how logic works. Logic is a pretty important algorithmic understanding that you need to know for programming. So I want to go over that first. But an if statement is a program itself. So I copied a definition from online. If statement are basically a logical block used within programming. So what that is an if statement is allows the computer to make a decision by following the conditional statement. The conditional statement would be a logical expression as we demonstrated earlier. So for example, we put if left parenthesis, conditional statement, right parenthesis, and then the code within the brackets would only be executed if the conditional statement is true. So in the case of the question I received earlier, you would use or within a conditional statement within an if statement. For example, if x is equal to 4 or x is equal to 5, then run the underneath code, and that would be a valid statement. So does that make sense? So it allows us to test things in stuff that we evaluate in Java. Basically, if we don't know a variable, for example, if we get a user inputted variable and we set x equal to a variable, we can check to see what the user inputted variable is with an if statement. We can also use if statements to do other stuff, for example, printing a statement based on something or returning a value in a method based on an if statement. So does that make sense? So by itself, a logical expression basically is not a statement. You have to use it as it's called a conditional statement, and you only use it within an if statement. Yeah. You could also use it within a while statement, which is a type of loop, but I have not gotten to that yet, and we'll get to that in a later class. Okay, so no one's asked me any questions, so I think we are more or less good to go. Okay, so following on the else if statement, on the if statement, there's the thing called an else if statement. By itself, an if statement only allows us to check one condition, right? So if we want to check multiple conditions, for example, if we check one condition and it's false, we don't want the code to just exit. We want to check another condition separately, then we use an else if statement. So the example I give here is if some condition, if this condition is not met, then the code is in the brackets here. This code would not be run. But if we want to test another condition, else we use an else if statement, else if different condition, and then this condition will be checked to see if some different set of code is run. So this allows us to run different results in code for different conditions if different conditions are met. For example, if I have an elif, I'm not sure if that works in Java. I know that elif is a shortcut used in, I think, C++. Elif works. I mean, if by itself is not that long of something to type either. So, I mean, I don't think it's necessary. Oh, elif is Python. I'm not sure. I'm pretty sure it's just a shortcut for else if in C++ as well. Not sure. But in general, actually, Java is not that lenient on using simplifications. For example, in like C++ or other languages, you can get rid of like the system.out.println or whatever using like a cout or using namespace, whatever. But in Java, you can't really do that as far as I'm concerned. So in Java, you should just stick to what I teach. Like you're not writing that much more, and it doesn't really save you that much time. So I don't see the point in simplifying it, I guess. Plus, using else if and whatever, it makes the code more readable. So that's my opinion on that. So I want to check for understanding between the difference between an else if and an if statement. So can someone tell me the difference between the results of running the left hand code and the right hand code? Okay, so no one's, okay, yeah. Left prints 2 and the right will only print Java once. That's correct. Because an else statement is only run if the if statement above it is evaluated to false. Since 4 is less than 5, in this scenario, it would not be run. So that's correct. And we can check this, I think. Wait, technical difficulties. Okay, so I don't know. Let's use REPL. That's awkward. Not a statement. Let's see. Not sure what's going on. System.out.println. Well, I don't know. Hopefully, I'm making a dumb mistake here. If someone can point it out, what I'm doing wrong, that'll be cool. But if not, I think it's just. I'm pretty sure you do not need to import java.io for system.out.println. Yeah, I don't know. Yeah, it would. Yeah, if you don't include the quotes, it should be. Okay, yeah. So the problem was that I copied and pasted it, so it didn't recognize the quote signs. So typing in the quote signs directly would fix the problem. Apparently, the quotes are different between Google Slides and on Java itself. So you see here in the result here that there's 2 Javas as expected, but if we change it to an else if statement, it'll be 1 Java. And yeah, so java.io is not needed for some of the basic commands. Yeah, so 1 Java is printed in this scenario if we use an else if, which is basically what we predicted. That was really weird because apparently REPL does not cares about like the different types of quotes, forward and backwards quotes, which are used in Google Slides. So that's awkward, I guess. Is it next to, should be facing the other way? No, the brackets are correct. So when you want to do an if statement, you do an if statement, an if plus a conditional statement, and then you do an open bracket followed by everything that you want to run if the condition is met, and then followed by the closing bracket. So yeah, we basically check to see that conditional statements do indeed work. And that's REPL. REPL is pretty good online, simple to use IDE. How do you download Java? Download Java? Well, as I stated earlier, we usually use BlueJ, but there are a lot of resources in which you can basically get Java for, you can basically use Java online simply. For example, I use the website called repo.it. I want to just demonstrate to you guys because this is a relatively simple project example. So you can use REPL, which is directly online. You don't have to download anything. But in general, as I mentioned earlier, you should, and for this class, I recommend BlueJ. So you download that by searching up BlueJ online. All right, so I kind of went on a tangent there with checking conditional statements, and I had a bit of difficulty actually running the code myself. So that's that. So I'll move on. Okay, so other than if statements and else if statements, one more statement I want to introduce would be an else statement. And so basically, if it's basically a general condition, a general code that's run when none of the conditions that you set are met. For example, if I don't know. So for example here, if condition 1 is not met and condition 2 is also not met, then everything else would run the code underneath else. And notice that else does not require a condition because it covers all the cases that have not been covered by if statements. And also, I want to say that you can have an infinite amount of else if statements, but for my scenario, I just have 1 if statement and 1 else if because I can't fit more here. So theoretically speaking, you could test like 10 conditions before putting else statement at the very end. And also I want to, I guess, sort of like a public service announcement or like a warning or something like that, is that you cannot use 2 else statements after each other because the second else statement will not be reached because else covers every single case other than the conditions already listed. So after an else statement, all the conditions have already been tested. So another else statement will not be needed and won't be reached. And you might even encounter an error if you do that. So does anyone have any questions in regards to if statements, else if statements, and else statements? All right, so no questions? If so, I guess I'll move on. So as I said earlier, like logic and algorithm, a lot of that is like logical thinking. So I want to go into more complicated examples of logical expressions. And a good thing to know would be how to evaluate these logical statements. It's both a good test of your knowledge, and also I'm pretty sure it does sometimes come up in your coding. So one good example of testing like more complex examples uh, of logical expressions would be DeMorgans Law. And in this case, A and B could be expressions that either evaluate to true or false, or they could be Boolean variables that are set to true and false by themselves. A reminder that Boolean is a type of variable that can be either true or false, and they are generally used in conditional statements. So DeMorgans Law states that not A or B is the same as not A and not B. So we can test this logic using what we call a truth table. So I'll attempt to exit. Oh, yeah. Okay, so what a truth table is you can test to see if the results of every possibility in you can test to see if every possibility in a logical expression is the same for two scenarios. Since DeMorgans Law claims that these two expressions are the exact same, then they should every single scenario combination of true and false for A and B should result in the same final result for this expression. So if we have A is true and B is true, then A or B will be evaluated to true. That's because as long as one of these is true, then A or B is true entirely. So therefore, not A or B will be evaluated to false because not true is false. If A is true and B is false, one of A or B would have to be true, which is true. And we do the same thing for false and true because A and B in this instance are interchangeable. So we get false, false, false. And finally, if A and B are both false, then A or B is false because both of them are false. And that's the only scenario in which it evaluates to false. So not A or B would be true. So we want the following logical expression to evaluate to the same thing as what we see here, false, 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 true. So I guess we do that. So for true, if A is true and B is true, then not A would be false and not B would be false. So not A and not B in this instance. So is false and false is false, so be false. Basically, an statement is both of them have to be true for it to be considered true. Otherwise, it is false. And since neither of them are true, then not A and not B are both false. So the entire statement is false. And then using the similar logic, I'll do this a bit faster because you guys should probably understand how I'm doing it. It's similar to the way we do it above. For both of these scenarios, if one of A or one of B is true, then one of not A and one of not B would be false. So therefore, not both of them are true. So therefore, the entire expression evaluates to false. And so if we compare the results for A and B, every scenario of A and every scenario of B results for the same results for the logical expressions, not A and not B, and not A or B. So we proved one of these statements. Another way in which we can visualize logical statements is by using what we call a Venn diagram. So let me try to annotate. I haven't done this before, so this should be interesting. Okay, so for this left statement, it would be something like A covering, if this is A, okay, my drawing sucks, I guess. Shoot. We clear this. Okay, we try again. Okay, I'm not gonna label it because writing is hard. If the left circle is A and the right circle is B, then A and B would be all of this. Just use a text box. Oh yeah, I could probably do that. But you can't draw circles with text box. So you can use Venn diagrams, which is sad. So not A and B would be everything outside of A and B would be the union of the two Venn diagrams. So it'd be everything outside like that. But for the right case, if this is A and this is B, not A or not B, you can make circles in the annotation box. You can do that. I have to test that out on my own, I guess. It would be the same result because we noticed that if it's not inside A, it would be everything outside, like in B and everything outside this entire circle. But not B covers everything inside the left circle, but not inside the right circle. So the only thing left not covered will be the inside. So using Venn diagrams, basically, you can prove, you can solve logical expressions as well. So I want to give two examples of how to solve a logical expression, one using truth tables and one using Venn diagrams. All right, so that's all good. And I don't think I'm ever going to try to draw again. That was awful. So I want to give you guys some exercises so you can actually, yeah, we learn from our mistakes. That's nice. So I want to give you guys some exercises. So I found this website called Coding Bat, which you can use for practice in both Java and Python. So if you guys taken Python and you guys didn't learn about this, then learn to draw. I can draw. I just can't draw with a mouse. Then you guys can go to Coding Bat for more practice. And I'll show you guys what I mean. So you go to codingbat.com/Java. You can also search up Coding Bat on Google. It will be the first link. You don't have to download anything, which is really nice. And so we did logic statements and evaluating and using if statements and if else whatever. So I found a few of these problems really test that, and they're relatively simple as well. So you guys can work alongside me and see if you guys can solve these questions by yourself. I'll try to work a bit slow, but hopefully, so you guys can start to sleep in, and I'll catch up to you guys, I guess. Hopefully you guys can look at what I'm doing and see if it's the same as what you are doing, and then yeah, that will be the exercise for this class, I guess. So for this one, the parameter weekday is true if it's a weekday, and the parameter vacation is true if we are on vacation. Sleep in occurs if it's not a weekday or we're on vacation. Return true if we sleep in. Okay. So first we have to test to see if it's weekend or not. So I can use this question as a sort of review for what we taught about methods earlier. So you see here, Boolean defines the return type. So therefore, we are trying to find a Boolean, so a true or false value to return. And this is the function name, method name. And these two are what we call parameters, which is information we get when we call on a method. In this case, the parameters are weekday and vacation. So these two variables are already defined for us, so we can use them as a Boolean, true or false, directly. So with this in mind, okay, so we can first test to see if it's a weekday or not. So if it's a weekday, we sleep in, so we return true, lowercase return. And then else, if vacation it's not a weekday. Okay, so here's where some of the logical expressions we learned come in handy. So if it's not a weekday, then we return true, and we use an else if statement. Else if vacation is true, then we also return true. And if none of these conditions are met, we return false. Right? So we test this, and it's all correct. Yeah. Yeah, you can combine it into an if statement with an or logical operand, but I'm a bit too tired to do that, and this is much simpler. And also another thing to keep in mind is that when we're writing conditional statements, we would usually write equals true or false, where in this instance to see if the left expression is evaluated to true or not. But in Java, it's implied that if you don't check to see if it's equal to something or not, then it's implied to see that you are checking for if it's false. Checking for if it's true. So for this instance, it's implied that we write this following part of the code. This is implied, so we don't need it, but it makes much more sense for like a reader of the code if you write it, I guess. So I guess we can do the next one. A smile or B smile. So I'll try to use a logical operand like an and or an or for this question. We are in trouble if they are both smiling or if neither of them is smiling. Okay, so we are only okay, so if a smile if not a smile. I'm gonna write the code first, I'll explain. Shoot. Oh, I guess capitalization matters. Unfortunate. Yeah, so this is all correct. So basically, I did it pretty simply. I just said that if they're both smiling, which is A smile and B smile, or if neither of them is smiling, not A smile and not B smile, then return true. For all other cases, return false. So that's basically, I'm just trying to put the words into a logical statement directly and doing it pretty straightforwardly. So and that's pretty much all the time I have for today. I wanted to go over more exercises, but I guess I didn't do the rest of the lesson fast enough, so my bad for that. But that's it. Can you use symbols for underscores in Boolean names? Not sure on that. You can